Ammolite Explained Audioblog. Ammolite is a particularly rare and organic gemstone formed from the fossilized shells of an assortment of ammonites and marine cephalopods that existed sometime during the Mesozoic era. Though ammonite fossils are found globally, they're fairly ubiquitous, gem-quality ammolite is uniquely associated with the Upper Cretaceous Bear Paw Formation in North America, primarily in Alberta, Canada. This material is popular for a few reasons, mainly for its aesthetic properties and its scientific interest as an example of preserved biomineralization. Ammolite is composed primarily of aragonite, a polymorph of calcium carbonate, CaCO3, with an orthorhombic crystal structure. This is the same mineral found in nacre, mother of pearl, and is responsible for ammolite's signature iridescence. What distinguishes ammolite from other aragonite-bearing fossils is the exceptional preservation of its original microstructure, which is capable of diffracting light and producing a very distinctive multicolored effect. The aragonite platelets are layered in thin, stacked arrangements within the shell, and these microlayers cause light interference. The observed colors, reds, greens, blues, and violets, are not due to pigmentation, but the physical structure of the aragonite layers themselves, a phenomenon known as interference iridescence. The exact color depends on the thickness and spacing of these layers. Thinner layers tend to produce cooler colors, blues and violets, while thicker ones yield warmer ones, reds and oranges. The Bear Paw Formation, dating approximately 71 to 75 million years ago, was deposited in the western interior seaway, a vast inland sea that once divided North America. The ammonites that would become Ammolite lived in this marine environment and were buried in fine-grained sediment rich in volcanic ash and silt and organic matter. Crucially, the preservation of aragonite was made possible by low oxygen depositional conditions which limited microbial activity and prevented recrystallization into calcite, a more stable but non-iridescent polymorph of CaCO3. Over time, the surrounding sediment lithified into shale, compressing and then stabilizing the ammonite shells. In some cases, trace elements such as iron, aluminium, silica, and magnesium were incorporated subtly, influencing color and structural durability. Natural ammolite is actually pretty fragile. The aragonite layer is often less than 1 millimeter thick and may be fractured due to compaction and geological stress. For this reason, most commercial-grade ammolite is actually stabilized. Doublets are formed by bonding the ammolite layer to a backing of shale or quartzite. Triplets, on the other hand, include a transparent capping, usually synthetic spinel or clear resin, to enhance durability and luster. While these treatments assist the stone's wearability, untreated natural ammolite specimens are highly sought after by collectors and museums for their rarity and scientific integrity. Gem-grade ammolite occurs in a very narrow geographic range, with the richest deposits found along the eastern flank of the Rocky Mountains. It was originally recognized as a gemstone by the World Jewellery Confederation in 1981 and is considered one of the few organic gemstones, alongside things like amber and pearl and coral, things that aren't quite minerals but share enough of the qualities to be at least considered gemstones. Its commercial availability remains very limited due to its geological specificity and the care required in extraction and preparation. Moreover, it serves as an example of exceptional fossil preservation, where original biological structures persist in recognizable and optically active form for over 70 million years.